Good evening, everyone. Hope all is well. Hope everything is all right. All right. So, anybody have any questions or concerns before we go ahead and get rolling? Everybody good? Pretty straight. All right. So last we talked, we did derivatives. All right. So let's look at 3.4. Derivatives as a rate of change. I have to write something so it'll look a little sloppy, but all right. So the derivative as a rate of change. All right. So looking at displacement first. And that's the movement of an object along a coordinate line. All right, so position S. So we use S to represent our position S on that line as a function of T. All right, so S of F of T, S is equal to F of T. So S is going to be our function. So that change that we're talking about when we talk about the movement, whenever you see delta, that represents the change in, whatever letter. So if you saw delta Y, that's the change in Y. Delta S represents the change in S. So if you see that notation, that's what they're referring to. And it's the same thing as, write this over here. All right. We're going to get back to this in a second, but just showing you notation. All right, so velocity is the derivative of position with respect to time. So V of T is, like I said, derivative of your position. Remember, position is S for us with respect to T. Derivative of S with respect to T. So your velocity is how fast an object is moving along the horizontal line. All right, and then speed measures the rate of progress regardless of direction. All right, it is the absolute value of velocity. Notice they spelled out the word speed. They didn't use S because remember S represented position. So I was throwing that out there. Then we have acceleration. That's the rate at which the body's velocity changes. All right, and it measures how quickly the body picks up or loses speed. All right, so the derivative is going to be I said the derivative. The acceleration is going to be the derivative of the velocity. So it's either derivative of velocity or second derivative of your position. Same thing. Jerk is a sudden change in acceleration. And that is the derivative of acceleration. All right. Any problems? Can I scroll up? All right, so let's look at an example and try to use some of these things that are just been presented to us. In a free fall of a heavy ball bearing released from rest at time equal to what time being t equal to 0 seconds. So okay, downward jerk. How many meters does the ball fall in the first 3 seconds? Give you a chance to write that down before I scroll up. All right. So the metric free fall equation is S of t is equal to 4.9 t squared. And any equation that they want you to use, they will give it to you in the equation in some form. So just simple substitution. How many meters does the ball fall in the first 3 seconds? It's 4.9 times 3 squared, which will give you 44.1 meter. All right. Any problems with the first one? All right. B, what is the velocity, speed, and acceleration at t equal to 3? All right. So first thing, if you want to find a velocity, remember that's the derivative of position. Our position formula was 4.9 t squared. So remember, whenever we're doing derivative, that 4.9 is just a constant. So that stays on the outside. It's not affected by the derivative. Then as far as t squared, bring the 2 down, subtract 1 from that. 2 is your exponent, so it'd be t to the first power. So it's just 2t. And then 4.9 times 2t is 9.8. Oh, 9.8t. I left off the t with 9.8t. So 9.8t is the velocity. Plug in 3. That's 9.8 times 3, which is 29.4 meters per second. All right, any problems with that? All right, ask us to find the speed. Don't forget the speed is just the velocity, absolute value of the velocity. And so that's just 29.4 meters per second. All right. Then acceleration is the derivative of your velocity. So taking the derivative, let me see something. Yeah. Hold on, what is this down here? Oh, that was probably something that somebody asked. Okay. So taking the derivative of your velocity, we had 9.8 t as our velocity, and that's just 1 for your exponent. So that doesn't change anything, just 1 times 9.8, and then 1 minus 1 as far as your exponent is concerned. That's what I was writing right here. And you know it's going to give you 0. So all you have left is 9.8. So it doesn't matter what your seconds are. 9.8 meters per second squared is your measurement here, if they were to ask. All right. Any questions on what we did on any of that? And then when you look at the numbers, if you go back, I'm scroll back down, but if you look at what these mean, you know, the velocity is derivative of position with respect to time. So your velocity could be speeding up, which is positive, or slowing down. You know, it's how fast an object is moving along the horizontal line. Speed is measures the rate of progress, you know, no matter what direction. And the acceleration is the rate at which the body velocity changes. And so that's what we just found for each one of those. All right, is everybody done with acceleration? This in the red is evidently was something that somebody asked, you know, during that class period. So it has nothing to do with the problem. The problem actually ends right here. All right. Let's look at another one. So a dynamite blast blows a heavy rock straight up with a launch velocity of 160 feet per second. So it's about 109 miles per hour. It reaches a height of 160 t minus 16 t squared feet after t seconds. So that's the equation that we will be using. Give me a chance to write this down before we scroll up. All right, let's scroll up. So it says how high, the first question is how high does the rock go? All right, so if we're talking about what's actually going on here, go back to the problem. It says the dynamite blast blows a heavy rock straight up with a launch velocity of 160 feet per second. So the rock is going straight up into the air. It started down on the ground, but then it goes straight up. It says, how high does the rock go? So it says right here, the sentence, it reaches a height of S equal to 160T minus 16T squared. So that's the position. And it's going to get to and that's what I wrote right here in the red. It's going to get up to this point and it's going to stop and then it's going to come down. So it's going up to a certain height and then it's going to come down. So basically you want to know, when is your velocity equal to 0? So it's going to come up to a point where it stops. And so at that moment up in the air, before it comes down, that's the highest as it goes. And that at that point, the speed or velocity is 0. All right. Any problems with that before we go ahead and do work? So remember, velocity is the derivative of your position. And they gave us this formula right here, or equation, that our position will represent 160T minus 16T squared. So we need to take the derivative of that. And that's what we're doing right here. Derivative of 160T is just 160. Then we have 16T squared, bring the 2 down, subtract 1 from the exponent. And then that 2 times 16 is 32. So we have 160 minus 32T as our velocity. So remember, the question is, though, we want to know, when is the velocity equal to 0? So we take that equation and set it equal to 0. And, from there, we will go ahead and solve for x. I'll say x, but t. So I'll go ahead and add 32t to both sides. And then divide by 32. And t is equal to 5 seconds. So it will reach its height at 5 seconds. All right. So now that's solved for t. It's going to reach its height at 5 seconds. But if I'm not mistaken, it asks us how high does it go? So we're not finished yet. That's just telling us at 5 seconds, it will reach its height. That's when your velocity is 0. So now we go back to our position formula. And we plug 5 into the formula, into the equation. I keep calling it a formula, but it's an equation. Try to draw my 5s better than my s's. All right. So 160 times 5 minus 16 times 5 squared. 5 squared is 25. 160 times 5 is 800. 16 times 25 is 400. And so 800 minus 400 will give us 400 feet. So it will reach its height at 400 feet. All right. Any problems? Any problems? Scroll over. So what are the velocity and speed of the rock when it is 256 feet above the ground and above the ground on the way up and then on the way down? All right. So even though it's going straight up and straight down, no matter how skinny the parabola is, it's still, a parabola is going up and then it's coming down. And so first we want to figure out when is the velocity or when is 256 feet. So we want to know when is it going to be 256 feet on the way up and on the way down. So it's going to be two different times when this rock is 256 feet. Like I said, once on the way up and then the other on the way down. Sound like somebody was out there. That was a package. And of course, we use the position formula to figure that out. All right. So we're going to set the position formula. Keep calling the formula. Position equation. And I called it a formula right there too. It's an equation. I guess it could be used as a formula. I like to say equation better. So position equation set it equal to 256 because we want to know when is it equal to 256. I went ahead and added 16t squared and subtracted 160t from both sides so I can set one side equal to 0 and solve my quadratic equation. That's all I did there, just set one side equal to 0. Then I factored, pulled 16 out of each term. Factor the trinomial. Got t squared minus 10t plus 16. So that's t minus 8, t minus 2. Then we set each part equal to 0 and solve. So I have t equal to 8 and then t equal to 2. All right, pretty good so far. So these are the two times that the rock would hit 256 seconds, or 256 feet, excuse me. All right, so if we want to know the velocity, So I done with the purple. We want to know the velocity. Remember, we know the velocity formula. Keep going for velocity equation is 160 minus 32t. So we plug in 8 and plug in 2. All right, and we see that at 8 seconds, it's going down. So that's why it's negative. 96 feet per second. This is when it's going up. That's why it's positive. And then the absolute value of either one of them, of course, will get you 96 feet per second is the speed. The speed doesn't matter. Velocity has direction, whether it's going right versus left, up versus down. That negative sign versus a positive sign will let you know. All right. Any questions? Any questions? I'll scroll up. And here's what is the acceleration of the rock at 80 times after the blast. So, as we discussed before, acceleration is going to be the derivative of your velocity. So we have derivative of 160 minus 32t. Derivative of constant is 0, so that's why derivative of 160 is 0. And then the derivative of negative 32t is just negative 32. And just like before with that 9.8, there's no variable. Oh, let me do that. So this means that the acceleration at any time after the blast will be this. And so the other note says the acceleration is always downward and is the effect of gravity on the rock. All right, can I scroll up? And it's just another statement. As the rock rises, it slows down. As it falls, it speeds up. All right. Any problems before I scroll up? All right. Got another one. Says, when does the rock hit the ground again? So once again, we're talking about position. We want to know when is the position 0. So we set that 160t minus t squared equals 0. And we can solve for t. Factoring out 16t. All right, solve for both. And so of course it was twice that it was 0 because that was in the beginning and at the end. So we have our initial position is when t is equal to 0, but then our final position would be when t is equal to 10. So it hits the ground at 10 seconds. All right. Questions on anything? Mhm. Any problems? Any problems? All right, can I move off the screen? All right. So 3.5 derivative of trig functions. Nah, we can hold that for next class. So this was enough right here for today. I don't want to throw a lot at you. I don't want to throw too much at you, not give you a chance to digest, you know, this section and what we're doing here. So before we close out, send you guys into the weekend. Questions on anything? Any problems? All right. So don't forget to knock out that chapter 2 stuff. And whenever you do your test, don't forget to send me a scratch work for your test. We got to go all the way to 3.8, so we got a little time for chapter 3. But make sure, like I said, you get in there, and if you have any questions, make sure you ask me. All right. So before we close, everybody good? Anybody have anything? All right. So I will see you guys next week. Be safe and have a great weekend.